Hi, I'm Daniel, and we are going to discuss the trends of the periodic table.
But first, let me go over the different sections that we see on the periodic table. These elements are known as the metals. These elements are known as the nonmetals. The elements touching this stair-step line are called metalloids. Groups 1A and 2A are your S-block elements. Groups 3A through 8A are your P-block elements. Groups 3 through 12 are your D-block elements, and your lanthanides and actinides below the periodic table are your F-block elements. Group 1A on the periodic table is known as the alkali metals. Group 2A is known as the alkaline earth metals. Group 3 through 12 are known as the transition elements. Group 7A is known as the halogens. Group 8A are the noble gases. Now, let me show you some trends that we see on the periodic table.
Here we have our neutron, Spencer, and there our proton, Hope.
Atomic radius.
As we add one electron, it's going to be a good distance away from the nucleus. There's not that much attraction between the proton and the electron. As you go across the periodic table, however, you are adding electrons and protons, and the attraction strengthens. Here, we have added an energy level, 2 in the first, 8 in the second. First, I'm going to have to explain shielding to you. Now, shielding occurs when you have more than one energy level. You know when you're trying to use a remote on the TV and somebody walks in between, and it makes it so there's bad connection or your remote doesn't work? Well, it's kind of the same thing here. When you have an energy level in between the nucleus and another energy level, the attraction between that energy level and the nucleus kind of weakens. There's something in between it taking over some of that attraction. As you move down a group on the periodic table, you're adding energy levels, thus making it less and less of an attraction between the nucleus and the valence. So it gets farther and farther away.
Ionization energy.
Ionization energy is the energy needed to take an electron away from an atom. As you go across a period, you're adding electrons, therefore getting closer and closer to the nucleus. Say, Hope here, the proton, loves her Mountain Dew a lot. When you have fewer Mountain Dews, she doesn't need to keep an eye on them, so they get further and further away. But that means it's easier for me to sneak up and steal one of them from her, because they're not close to her. As you add Mountain Dews, they're closer and closer to her. So as soon as I go to steal one, she sees me and she's able to keep it. It's like with ionization energy. The closer they are to her, or the more electrons you have, the harder it is to take an electron away. The closer the electrons are to the proton, the more energy is needed to take the electron away. Thus, ionization energy increases across a period. Now, as we add energy levels, like I said earlier, the atomic radius increases. More shielding occurs, and the attraction between the protons and the electrons weakens. Which means, as you go down a group, it's easier for me to take one of these electrons away. Opposite of the periodic trend, like I said, you add electrons, they get closer, and it's harder to take them away.
Electron affinity.
Electron affinity is the energy an atom gives off when it gains an electron. As you go across the periodic table, you're getting closer and closer to a stable state, or a stable octet. Now, she wants 8 electrons. She wants 8 Mountain Dews right here. So the more she has, the closer she is to getting 8, the more she has, the more she's willing to spend for me giving her one. As you go down a group, you're adding energy levels. More shielding takes place between the nucleus and the electrons. Now she's already spent all her money on all of these valence electrons and the energy levels in between. So she has less money to give me when I add an electron.
Therefore, electron affinity decreases as you go down a group. Ionic size.
As we get into ionic size, there's a couple terms we need to get straight. First are cations. A cation is a positively charged ion of an atom. Electrons are negative, protons are positive. So if I take away an electron, the whole atom has a positive charge. An anion has a negative charge. The electrons are dominant. In cations, there are less electrons, so the attraction between the nucleus and the electrons weakens and the ionic radius gets bigger. In anions, you're adding an electron, the attraction gets stronger, and the ionic radius gets smaller.
Electronegativity.
Divided by this line, we have two atoms that are bonded together. This one's protons and neutrons are represented by these delicious candy canes. Now, electronegativity is the attraction between this atom's electrons and this atom's nucleus. As you go across the periodic table, you are adding electrons and protons. The attraction between this nucleus and these electrons gets higher and higher. The electronegativity rises. As you move down a group, you're adding energy levels. Like I said, shielding takes place, and the distance between the nucleus and the valence electron gets bigger and bigger. As the distance gets bigger and bigger when you add electrons, the distance and attraction between this nucleus and these electrons gets less and less. Thus, electronegativity gets less and less.
And now, a brief history. A long time ago, in a country far, far away, lived a man named Hennig Brand. Though he didn't discover the first element, he is credited with discovering the first one through experimentation in 1649. In the next 200 years, over 60 elements had been discovered. In the 19th century, chemists like Johann Dobereiner and John Newlands began to see and document trends among elements. In the 1860s, both Lothar Meyer and Dmitry Mendeleev published very similar tables that were organized by atomic weight. The beginning of the periodic table that we see today is credited to Glenn Seaborg, who discovered the elements 94 through 102. He reorganized the periodic table with the lanthanides and actinides below the table. For this work, he received the Nobel Prize, and element 106, Seaborgium, was named after him. Did you know color copiers use selenium to transfer the images from the negatives onto the paper?
It's periodic trend, oh, 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 it's periodic trend, oh, 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 it's periodic trend. Everybody know the periodic trend. Hey, know the periodic trend. Everybody know the periodic trend. Hey, know the periodic trend. Everybody know the periodic trend. Hey, know the periodic trend. Everybody know the periodic trend. Hey, know the periodic